Hi everybody and welcome to Data Science and Society. My name is Professor Bale and it's my privilege to teach you today about the kind of basics of data science for social good. So it's hard to begin a class like this without talking about COVID-19. It affects nearly every corner of our lives, and in fact it's become cliche to say that the coronavirus has touched every corner of our lives. But one of the unique things we're going to learn about in this class is the various opportunities for what social scientists call digital trace data, things like social media, Google searches, and other types of digital traces that we leave behind on our smartphones, on our social media accounts, whatever, that can help us gain new insights about where the virus is spreading and how. So one example, this one is created by researchers at the University of California, looked at Twitter. Here you can see in this map a visualization of where people are tweeting about coronavirus right now. And this particular tool tracks things like hashtags, so hashtag COVID-19, hashtag coronavirus, hashtag wear your mask, and it allows you to kind of mouse over any one of these single hashtags and look at where they're being discussed across the country. So on the one hand, this is pretty cool. Years ago, if a social scientist wanted to study whether people are, say, complying with social distancing directives or mask wearing directives, we'd have to do a survey. And surveys are expensive, they're time consuming, and people don't want to do surveys. And so social media, especially Twitter, which is very generous in sharing its data with us, gives us a kind of microscope to kind of peer in to what's going on. The big question is, who's doing the tweeting and what are they tweeting about? Well, first, let's look at that first question. How many people use Twitter? Probably many of you don't use Twitter because 23% of the US population does not use Twitter. So right off the bat, we're looking at a fairly skewed picture of coronavirus. On top of that, Twitter users skew a little bit urban and a little less rural. So as you look at this map, you may be noticing that the blue dots are illuminating around big city centers and not so much in the rural Midwest, say. Twitter users are also disproportionately likely to be non-white. And so here, again, we're getting a sense of what's going on from a part of the population that is not representative of the entire population. There are, of course, interesting questions we could ask looking at non-white populations. And if we were looking at, for example, whether or not the virus is spreading in minority communities more quickly, Twitter could provide kind of an interesting lens, but it wouldn't be the end-all be-all. Why? Well, we all know that Twitter is not real life, that Facebook is not real life, that Instagram is not real life, that TikTok, no, I'm not going to go there. So, here's the thing. What we put out there online is very selective, right? We don't tend to put out negative information about ourselves very often, or at least most people don't. And so what we're left with is a kind of record of what people wanted to share with the country. If we were to use this data to try to track coronavirus, we would probably come up with an extremely skewed version of where coronavirus is going. Not only because we're getting this skewed sample of the population, only a small part of the population, disproportionately urban, disproportionately non-white, but we're also getting what people wanted to share. And though some people certainly are tweeting about symptoms or having coronavirus, others are experiencing deep shame about getting the virus. And so we simply can't use things like Twitter as a record of human behavior. The story of all this actually goes back farther than the coronavirus. Here what you're seeing is a graph of the prevalence of influenza-like symptoms over time, over about the last 40 years or so, 60 years, sorry. And you're seeing different rates, right, of the prevalence of these kind of symptoms over time. And the Centers for Disease Control, which is the large organization within the US government responsible for tracking things like influenza and coronavirus and other pandemics, was spending a lot of money trying to figure out where influenza was going. Influenza, as you may know, kills a lot of people each year. It's a major killer, particularly elderly people. And also, the CDC just wants to know things like where is the vaccine working and so on, the influenza vaccine, for example. And so what they do is yearly or weekly or monthly surveys of doctors, hospitals, and also people in the general population. What they're trying to do is to figure out where people have these kind of influenza-like symptoms, fever, chills, etc. So as you might imagine, this is a lot of work, collecting all these data from lots of different hospitals with lots of different record-keeping conventions, and also asking people to report their symptoms. People often don't want to talk about being sick, or maybe they're not answering the phone. So there's a lot of reasons why people became excited about 5 or 6 years ago about using some kind of digital trace data, again, these kind of digital records of human behavior, to try to track what's going on. And so one clever data scientist within Google came up with the idea that Google searches could perhaps provide an interesting lens into where influenza was spreading. This was around 2014, 2015. And what they realized is that if you track searches for things like symptoms like fever, chills, do I have the flu, what should I do to get rid of my flu, right? All these type of searches were giving people clues about where influenza was spreading. And people got really excited because the Google Flu Tracker, as it became known, was extraordinarily precise. We were able to probe deep into what people were doing and thinking simply by looking at their Google searches. And that was a really exciting moment for social science, which often doesn't have the same depth of data and the opportunity to run experiments as people in other fields. And here's how well it worked. We're going back to 2009 now, and we're looking at the estimated prevalence. They were able to go back in time by looking at Google searches before the tool was built. And we can see from about 2009 to 2012, the Google flu trend, pictured here in orange. On the x-axis is time, and on the y-axis is the prevalence of influenza-like symptoms. And what you're seeing is Google Flu tracks the CDC estimates almost perfectly for a really long time, too, for about 3 years. So this got people really excited. Everybody wanted to know, could this scale? Could we use this? Could this maybe even replace the surveys that the CDC had been doing to track the flu? Great idea. We can save money. We don't have to bug people with surveys. It's logistically much more easy. Why not do this? Well, the reason was that in the middle of 2012, on one very scary day, the Google Flu tool estimated the prevalence of influenza at about twice the rate of the Centers for Disease Control. And that's what you can see on the right-hand side of this graph. So as you might imagine, this caused a lot of alarm. People were asking, is there suddenly a pandemic spreading? Is something going on? And of course, there was shock and alarm pretty much everywhere. When they got down to the bottom of it, though, they discovered there was in fact no major influenza pandemic in mid to late 2012. What they were actually seeing was not people increasing their search behavior around influenza because they had underlying symptoms. Instead, on that day, Google changed the way that it serves people ads on the side of its page. And when this happened, people who, for example, had common cold and were looking for remedies to their common cold suddenly saw an ad on the side of their search screen for influenza or flu. They then began thinking, do I have the flu? And then started Googling as if they had the flu, right? And so what we actually observed is humans interacting with an algorithm producing something that looked like human behavior when it was actually just a product of the interaction of people with technology. This is something we sometimes call algorithmic confounding in the field of computational social science, which is what a lot of us like to call this type of work. Okay, so this was really disappointing. The Google Flu tool was meant to be this kind of wonderful example of the power of data science for social good, and it kind of fell flat. So we learned a lot from it, right? We learned about the dangers of algorithmic confounding. Now we know a lot about who uses social media, what type of digital trace data are out there, and we have new, better data. And to end on a kind of upbeat note, one of the remarkable things about the coronavirus pandemic has been the depth of data available from companies like SafeGraph that collect data from our smartphones that describe where we're going and when. Not everybody, but a lot of people who have smartphones leave Google Maps on. Google Maps is then picking up data about where we're going. And then this company, SafeGraph, aggregates that to a level where it's very difficult, if not impossible, to identify individual people, and then produces metrics like this, the so-called shelter-in-place index. And so here we're looking at the US over time, and we're able to see exactly where and when were people staying inside their homes throughout large chunks of 2020. This is the type of data we're going to look at in this class. This is the type of data we're going to think with critically to solve a range of different problems, not just in public health, though of course that's the critical question of the hour, but also questions on the horizon, questions about political polarization, questions about algorithms and discrimination, questions about our culture, and we're going to learn tools like social network analysis and text analysis to help you learn how to marshal these really wonderful and impressive new data to unlock insights about the social world.